Hi, good afternoon, everyone. Can people hear me okay? Good. How's everyone doing? Good, great. So today I'm going to talk about Python for like reliable delivery of the cross-platform products that we have. So this is a lot of big words. I'm going to take some time to actually go through these things. So a little bit of intro. I'm Avi. I work at Braintree, which is a company owned by PayPal, and I work with developer experience, and namely with SDKs and the tooling around SDKs. I'm from Austin, Texas, and this is my first time speaking at a conference, so thanks, Python Canada. All right, so a little bit of introduction. So when I'm talking about reliability here, it's in context of, well, firstly, we need to know that the tools that we have and the use cases are across, like a tool working well means like the mobile component, the web component, and the server-side component all working well together. And we want to make sure that the health of our APIs and SDKs are good. And we want to make sure that that is across live, sandbox, and our development environments. Quick overview of today's talk. We're going to try and go through building a minimum viable version of the testing pipeline that we have running. And these are some of the tools that we are going to use. We're going to use Appium for automating an iOS app. We're going to convert the Python code into behavior-driven tests in Behave. We're going to take the test data and we're going to put it into Elasticsearch, which I have running locally on my machine, and we're going to display it on Kibana. In production, we have it running in Jenkins, but we're not going to spend much time on that here. So this is like a lot of tools. I know like PyCon attracts like a very broad group of people, so I'm going to try to assume as little as possible about what people already know. Of course, like feel free to like ask me questions later. Okay, so talk about the particular product that we're trying to test. So earlier this year, we launched a product called OneTouch. So since we are a payments company, we want to make sure that our merchants are selling as much as possible. We want our merchants to make more money. And how we want to ensure that is by making sure that customers have as secure and easy checkout experience as possible. Since the more, since the less friction there is, I mean, there are likely to be more conversions. So to feel like a quick demo of the product, so the basic idea is that on like a particular device, when an user like tries to buy something on a merchant's website, the first time they go to PayPal's website and they log in with the username and password, but then subsequent times on a different app or like on a different website that they're browsing, it remembers their identity, so they don't have to log in again, so the experience is much better. This video right now shows the experience of someone who has already given that consent and now are buying something else. So let's look at this. They select to pay with PayPal, they agree and continue, they confirm their purchase, and the shopping experience is done. So we already have some great partners who are using this in production already. So let's talk about how this kind of works behind the scenes. So the components of this kind of go like this. So there's the merchant app, which uses the Braintree SDK, and that could be either iOS, Android. And the Braintree SDK wraps the PayPal library. And I mean, based on whether or not the user already has the PayPal app installed on their cell phone device, it could either switch to the particular app or it could switch to the browser. And based on the user's selection at that point. The user either selects to go through it or they select not to. At that point, it brings them back to the merchant app. So the PayPal app here, like this, there will be multiple versions. There is localization, internalization to be aware of. In terms, as far as the browser switch goes, there are different checkout flows that need to be aware of. As far as like when you look at it from like a testing point of view. So that's like the client side of it. The server side of it is that the merchant app then communicates with the merchant server because you can't complete like a payment completely on the client side just because of security reasons. And the merchant server presumably has one of our server SDKs, and that could be in like Java, Ruby, Python, or what have you, which then talks to the Braintree server, which then talks to PayPal servers. So, and these environments could be live or sandbox. So as you see, like there are a lot of combination of events, of outcomes that there could be possible. So the question is that how do we test all this, right? So to look into this, like let's look at what kind of requirements we had. We need to do automation for mobile and web. We need to make sure that someone who doesn't write code can actually make some sense of like what the tests are. So that's like the behavior-driven tests. And we need to display the data on dashboards and charts. So let's look at the architecture of the testing pipeline that we have. So Jenkins is the continuous integration system that we have, and the behave is the test descriptor and test runner. For the cases when we have, for our mobile use cases, we automate it by using Appium. For web, Selenium. And for the server-side use cases, we just have an interface in front of the different server SDKs that we have, so we can configure across which particular server SDK that gets used. And so by that way, we can test all the different configurations. So all this data gets put into the back into the behave formatter, which then parses and gets the data out in JSON format, which then gets into Elasticsearch, and finally we display that in Kibana. So a little bit of history on the project. The project actually started on PHP because the developer who started on the project was doing PHP at that time. But it was soon obvious that like although PHP is has like a very rich ecosystem for web, for our particular purposes, it didn't have the packages that we needed. So we switched to Python, and it worked very well for us. Let's talk about automation. So just like a quick raise of hand, has anyone here used Appium before? Cool. All right. So Appium essentially can automate an iOS, Android app, so be it like a native app, like an Cordova PhoneGap app, or like a hybrid in between. And it has like an API which is similar to Selenium. So at this point, I'm going to go to my code sample. So I have the bit.ly link, which you can find in the slides. And so yeah, so that's the so that's the repo, and it has the README and everything. So let's go to the app, which I have here already. So let's just try to, so let's just try to look at, oh wow. Okay, so let's just try to look into like the code base that we're going to run through right now. We include Appium and the Selenium dependencies that we have. We basically tell Appium what version of the iOS emulator we want, where the app lives, and then we tell it to connect to the Appium, which is actually like a node server that keeps continuously running. And then it waits for the launch button to appear, and once it finds it, it clicks on it, which then going to initiate like a browser switch, similar to like a real app, which could be browser switching to the PayPal website, where someone would be prompted to log in with their username and password. So at that point, after that, it would click on a button on the app, and we should bring them back to from the website back to the app. So let's try to run it. Okay. So Hi. Okay, so as you can see, yeah, it's a very complicated app, I know. It's just a simple app with just like the launch button. So it's trying to find the launch button right now. So after it finds it, it goes to the website and then clicks on it and then comes back to the app. So that's like the automating it with Appium part of it. So yeah, that's just like the example code for connecting it with Appium. So once we have this, the next set of requirements to look at was to convert this into real tests that are meaningful to someone who is a non-coder. So to this end, we use something called Behave. It's a behavior-driven framework in Python. If you have used something like Cucumber, it's very similar. It has features, scenarios, steps. These are just all different ways of aggregating these tests. To give an example, let's say like a feature, for example, like the app switch demo would just describe like a set of tests. One scenario would like correspond to one single use case that we have, and one step is just one individual action that happens. So, and then, I mean, you have other things you can do, such as you can use tags to group different tests, and you can use variables to pass in your different kind of data. So, at this point, I'm going to go to like the next code example. So, I'm going to check out. I'm going to check out the next tag, which is v0.2.0. This is all in the instructions. And let's look at this code base. So if we look into the feature file that we just talked about right now, so we have the app switch demo, and switch to app to back, and then simple app switch when Appium is installed. And the user clicks on launch, it's going to go to the website and come back. So this is readable by everyone. So let's look at the actual like implementation of it. So yeah, so as you can see, like this is just the previous example that we showed, but this time we include behave, and for every step. So given we have Appium installed, over here we're just specifying where the app lives. Then user runs app and clicks on that particular button. We describe that particular step, and step by step it just goes through the tests. So that's how the steps map to actual real code. So let's look into just running the test now. So you just run it with you can just run it with the behave command. So it tries to start running the test. So as before, it will bring up the app. It's going to try to find the launch button, and once it finds it, it's going to browser switch to the website, and then try to find that button on the website, which brings it back to the app. So that's like the behavior-driven component of it. Okay, so once we had some behavior-driven tests that we could describe, the next step was to actually use this, store the data, and do something meaningful with it. So to this end, when we were looking at options, we found Elasticsearch and Kibana to be really useful for us. Elasticsearch really allowed us pretty much any way we could think of dissecting the data. Elasticsearch's search functionality would provide us that, and Kibana provided us a lot of out of the box in terms of just looking at the data and really useful graphs and charts out of the box, so we could just start working with the data as opposed to just building it ourselves with like a JavaScript library maybe. Other advantages of Elasticsearch, I mean, it's JSON over HTTP interface, which is really useful to work with, since most people are familiar with that way of using interaction. So Elasticsearch, a quick Elasticsearch terminology. Elasticsearch has, if you're familiar with something like a relational database such as MySQL, a MySQL database and an Elasticsearch index can be thought of as something similar, and the database table in a relational database and Elasticsearch mapping can be thought of like somewhat similar. So how to install Elasticsearch? These examples are a little bit only focused on OS X, since I'm a Mac user, but I mean the tools themselves work very well on like Linux or Windows or what have you. So that's how you just go ahead and install Elasticsearch. So once you have Elasticsearch installed, you want to like configure the index and the mapping. Creating Elasticsearch index is we did it by using the officially supported Python binding. You just import Elasticsearch and you point it to for here I'm just using localhost, so I'm just going to use that, and I'm going to create an index called reliability. So once I have that, I'm going to then create a mapping. So for the mapping, I'm going to create a mapping called behave, and under the index reliability, and I'm going to pass in like a body of JSON. So the final output looks just like this. I mean, it's just telling Elasticsearch what fields there are in the database and what types they map to. Be they like string or integer or something else. And once you have all that, es.index is what you can use to tell Elasticsearch that you want to put like the result, you want to put like the body that came in to the particular mapping under the particular index. So let's get into the code example. So for this particular code example, let's first make sure that we have Elasticsearch and Kibana running. So over here, I have Elasticsearch running as a system process. I'm just checking for that. Let's make sure that Kibana is running. Kibana is running as a system process. And also, like another way to check for them is that you can go to your browser and just like by default, Elasticsearch uses this port. So we can call Elasticsearch and Kibana as well. So this is the basic UI of Kibana, and it just shows you by default that last 15 minutes it has not received any data. So let's try to get some data into Elasticsearch. So I mentioned a little bit before that to get the data into Elasticsearch, we actually need to format the data into JSON format, which is not the general output of the behave tests. So I'm going to first check out the the 3.0 version of the app, the repo, and then let's look into. So the way we can get this data into Elasticsearch is that we need to use a custom formatter in Behave. So Behave supports configuration files. So over here, we are telling Behave that I want to create a new formatter called record. And where to find the formatter? It would be under modules and under formatter record, and it's called record formatter. So let's go into modules and formatter record, and here we have the class record formatter. So without going into too much description about what this does, this basically parses the Behave data and prepares it for parses it into JSON. So once you have that, then you can run. So you can run the command, and you can tell Behave to use the record formatter, and I'm putting this data into results.json file. So we again get into doing that. So this is the same test. This is the same test we ran before, and this time we are using the custom formatter. As before, we click on the website and we come back finally. Okay, so if things went well, we have So as you can see, with the timestamp, we just created the results.json file. So what's in this JSON file? If we look into the JSON file, you can see that this is just describing all of what's happened in JSON format, the particular behave feature that we showed, and step by step, it just gives you the result of the test, how long it took to run, and so on. So once you have that, then you want to submit that result to Elasticsearch, as I mentioned before. So to that end, once we have this script inside the DB folder, submit to yes. So as I showed before, I already created the index and the mapping for Elasticsearch in my local machine. So I'm just going to take the results of JSON file and I'm going to submit it to Elasticsearch. So if we look into the main, we just use the JSON module, we just load in the data, and we do some post-processing and add some extra metadata, and we tell it what host it is on, what index to use, what mapping to use, and this line is probably like the most useful one, is to index the particular data and index it under the particular index name and the document type that we want. So let's go into doing that. So for that, all we do is just do Python p and okay. So it's telling me that there are like 4 out of 4 results submitted successfully. So let's look into Kibana right now and see if we have the data. Hey, so as we look into Kibana, we have the data showing up now in like last 15 minutes, just about now. So now when you look at this data, you can see that you have like all the step-by-step, all this data over here, time-stamped, and have all the fields that we were looking for. So now that you have the data, you can, you are in business. I mean, you can really get into it and work on this data. You can get into visualizing the data. I mean, Kibana has a lot of utilities such as data tables, line charts, pie charts, whatever you need to do. It's very easy to configure it and do custom searches on the data to convert it into the visualizations. And you can combine these visualizations and combine them into dashboards, which you can display. And you can configure your time ranges in which you want to search, and it also has things like auto refresh, which just keeps on pulling for the data. So once you're done with this kind of pipeline, and that's basically Kibana and installation. So this is just some examples of the kind of visualizations and dashboards that you can create using Kibana. Supports things like geographical maps. Histograms, bar charts, and so on. Just another example of something you can do with Kibana. So we need to have these tests running under continuous integration, and we do this using Jenkins. So Jenkins just gets the latest copy of our code and runs it, so we know that the latest copy is run, and it's pretty easy to interface to work with in terms of just running the jobs at particular time and monitor the history of the jobs. So what were some of the takeaways from this particular project? One of the biggest takeaways for us was that since our team is composed of certain people working on web, certain people working on mobile, and people whose core expertise is in PHP, .NET, and so on. But the fact that everyone could pick up Python meant that we could get everyone's contribution into the project. The other big part was that there is official Python bindings for like all the tools that we were talking about, and that was really useful for us to just like get started and get support when we ran into particular issues. And it also enabled us to get to just production faster and then iterate on it. So in the future, we would we want to improve this tool is that we would want to have better alerting based on certain events. We want to send meaningful alerts via emails or on our Slack channels. We want to be able to release parts of the project to the open source community, and I mean we want to use this to test other products that we have. So that's mostly it. I mean, these are some of the contributors who worked on our team, and this is their GitHub handles who worked on this project. That's pretty much it. That's my presentation. There's some helpful links for Braintree payments and Braintree, and all the code base is in GitHub. And I plan to put on the slides up there as well pretty soon. So yeah, do you have any questions?
If anyone has any questions, they could just come down to the mic here. I just had one quick question. I didn't totally catch. So you're using Behave, which is a Python BDD, like behavior-driven development library, and that's interfacing directly with the app driver. Is that?
Yeah. So Behave is essentially have the steps mapped to Python code. So and I mean as long as you have the Python Appium driver or the Selenium driver that can automate web or mobile, you can describe your test.
And so, sorry, is Behave is specifically for it has plugins for those two, or it's specifically built for those two?
Behave is completely independent from Appium or Selenium. So Behave pretty much is just used to describe the test. I mean, and underneath there could be anything. Yeah.
Thank you. Anyone else? Okay. Thank you.
Thank you.